Hi guys, in the last video we looked at taking a systematic approach to solving a 3x3 system of linear equations. In this video we're going to do the same thing, but the intent is going to be focusing on organizing your work since there tends to be a lot going on here. So looking at just some of the best practices when it comes to organizing our work, let's go ahead and start with indexing our equations. So remember that it doesn't matter, which one you call 1, 2, or 3. You can switch your equations around, but I tend to index them top, bottom, middle, and bottom is 1, 2, and 3. So what we're going to do is scan for a variable that is easy to cancel out amongst our equations here. So I noticed that looking at all of these, like our y variable here, let's see if I can move this to the front here. Our y variable all are multiples of 3, and so it'd be easy to scale these. And I even noticed that our first equation, this positive 3y, would cancel out with the negative 3y on our third equation. So in order to organize our work a little bit better, I'm going to go ahead and choose to delete or eliminate our y's here. And I'm going to start with our first equation and our third equation just because of the simplicity of the elimination here. So 4x plus 3y's minus 5z's is equal to 9. And this is a negative 9, so let's be clear there, Mr. A. And then we have 3x minus 3y plus 4z's is equal to 19. And because these y's already cancel, I'm just going to go ahead and do so. And what we get left with is this first modified equation, 7x's. Looks like we have a negative 1z. And this will add up, on the right side there, will end up being a value of 10. Remember that we are trying to be organized, so what I'm going to suggest is throw a box around this. Now, our goal is to make a 2x2 system with a couple of equations, but they have to have the same variables, so x and z here are our two variables. Let's set up a new pair of equations underneath this one here where we also cancel out our y's and get left with an x and a z. So I think it'd be most easily done if we take a look at the second equation and the third equation here, because the third equation has a negative 3y, whereas the second equation has a 6y. We could just double the 3 down here and get our second equation to help cancel our y's. So we're going to put our second and third equation. Let's rewrite our second equation. We'll just take our time. 6x plus 6y minus 3z equals 6. And we have 3x minus 3y plus 4z equals 19. Remember that we need to scale this particular coefficient so that they cancel. So we're going to take our entire second equation times a, just to be clear here, times a 2. Boom, 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 boom. So let's go right down the row here. What would our new system look like? Draw a double arrow down here. Suppose we would get 6x plus 6y minus 3z equal to 6. But this second equation now is going to read 6x minus 6y plus 8z, and that's going to be equal to 38. Now, going through this, I see that my middle variable cancels. I get left with 12 x's. Looks like we get left with a whopping a total of 5 z's here. And 38 plus 6 is 44. So I'm going to box this as well. Now, what I would recommend doing is off over here somewhere now, we can write 2x2 system using these two modified equations. So I'm going to put these together. 7x minus z equals 10. We also have 12x's plus 5z's equals 44. So looking at now solving this, we could use elimination. We could also use substitution. You could use a graphing method if you had a graphing utility. In this case, I'm going to use elimination. And it looks like it's easiest to eliminate our z variable here. This does require, though, that we scale our first equation, looks like by a 5 here. That way, when we scale it, our z's will cancel. So here's my double arrow. We're going to rewrite this again. We have 35x's minus 5z's, and this would be equal to 50. And then now I have 12x's plus 5z's equal to 44. Let's see what happens here. So my z's cancel. We get left with 47x's, and this is equal to 94. 94. So what would I do at this point? Well, this is pretty neat. We have one equation and one variable. Dudes, we can just go ahead and divide both sides by this 47. And what we should get is a solution here, at least for the x part. So getting out our calculators because we don't want to make any human errors here. Let's take our 94 divided by 47. And you may have already intuited this. Your intuition may have told you that x is a value of 2. So organization-wise, let's box it. Also organization-wise, let me recommend that somewhere, maybe next to your system, you write the word solution. I know at this point, because I have an x value in my ordered triple, I'm going to find these other two here. So let's go ahead and go through our task of finding out what our other remaining unknowns are. Remember that when you solve a 2 by 2 system, once you find one variable, we plug it back into one of the original equations to find the value of the other one. And I think that because we're solving for z, it'd be easiest to plug in this first equation here. So I'm going to write this kind of off on the side here. We're going to say 7x minus z equals 10. And I'm going to say, well, if x equals 2, then we can plug in 7 times 2 minus z equals 10. Simplify this now. 14 minus z equals 10. We can subtract our 14 over to the other side. And we end up with negative z equals negative 4, which, of course, when we divide both sides by a negative 1, implies that positive z equals positive 4. So I'm going to go up here into my ordered triple and say, dudes, z is 4. So the question we have to beg last is, so how do I find this y variable? Which there's always going to be one remaining variable that you didn't solve for in your 2 by 2 system. In this case, since we're solving for y, and since 2 and 4 satisfy any of these equations for x and z respectively, I'm going to choose the equation where it's easiest to get y by itself. And so that might just be the first equation or maybe the third equation here. I'm going to go after the first one. So the thing I tend to do is this, and it's kind of over here in this back solving step. I'm going to get my first equation out here. 4x plus 3y minus 5z. So I'm going to write the equation 4x minus 3y plus 3y and minus, so let's get this out of here, okay, plus 3y minus 5z. That is equal to negative 9. And at this point, we know the value of x and z. So what I'm going to do first of all is take those out. Since we're making a substitution, we always put in blank parentheses. And in this case, we're going to plug in for x. We found x has a value of 2 when z has a value of 4. So simplifying this now, it means that we're going to have to go ahead and do any multiplication and do any combining of like terms. So in this instance, the negative 20 and 8 on this side, I think that's negative 12. So we get 3y minus 12 equals negative 9. Now we can add our 12 to the right-hand side and then divide by 3, but we should get y is equal to 1. So in terms of organization, just making sure that you're using some of these best practices is going to help you organize your work a whole lot better. Cheers.